Let's see. Should be available if you want to join in. So for our scripts chapter, just like our other chapters, we've got Quizlet and assignment and your quiz. And I know you're working on your quiz for tonight for views. So looking at the chapter, if I go back to our chapter about views, let me get there. Chapter 13. Bless you. Whenever I'm reviewing to decide if I need to write any notes, this little quick table of contents is kind of handy, the way our book does that, to decide what parts of information I need to post in my notes. So their views were pretty straightforward, right? Did you find that when you were working on your homework? You should have seen that it's pretty straightforward. It's you know, as complicated as the data is, basically, as the select command is that we want. But other than that, they're pretty straightforward. So I'll add a tab here. That was chapter 13, views. And in my notes, I think I'll just put a view is a saved query, right? And we can create, modify, and drop views. So you guys have gotten pretty comfortable, I think, with that manipulation language syntax. So that's a meaningful note to us. We know what that means as far as the view object type that we work with. We use the as keyword, and it preceded the select statement, right? It comprises the view. So our select statement, don't have that, precedes 1C, 1E, before and after. See if I can zoom in without it going away. Great. Everything's looking good. Everybody's just been blazing through things, getting stuff done, it looks like. Try to get caught up to you. It's good. So what else would you like to say about views? Oh, we could have an updatable view. And for our updatable view, we saw that we had to have no calculated columns. And we can only update one table through the view. Anything else about updatable views that you can think of? Remember? And then lastly, we saw that we could use views of the system catalog tables. So we selected data through those views to see what was out there in the system, what tables we had created, what stuff we had going on there. Let's see, I guess we should say a view is a saved query. It is an object in the database. Because remember, whenever we looked at the views in SQL Management Studio, we couldn't actually see the syntax we had used to create that view. because once it's created, it's an object out there in the database. So we want to keep that SQL code ourselves separately as part of our source code. Now today we're going to look at scripts, and you've already done a little bit with scripts. You guys have kind of battled some things out and figured out some things when you've created your databases so that you could have the saved creation statements all together in a file and run that file as a SQL batch or set of batches to create your tables in another database or on another server. We also were thinking that in our program code, like if we had a C# program, if we saw that a database or a table did not exist, we could run the create table syntax to actually create that table on the fly from our code. So that's a really common thing for people to do. In programs, they'll have some sort of check set up to make sure that the database objects that they need exist, and if they don't, they'll run something to create them. So that'll just run one time on a given system, but it can make programmers' lives a lot easier that they don't have to go do something manually to create that. So we do all of that, called a script, whenever we save our SQL commands or create table commands or whatever it is that we're working with, we have our script. So whenever we're working with an SQL script, we actually refer to that as transact SQL. I'm going to put that in my OneNote note. So I'm going to create a new tab here again for chapter 14 and notes. And first of all, it's transact SQL, and we'll also see it called T-SQL, and that's the scripting language that's associated with SQL. So as we get into T-SQL for SQL Server here, we're going to see that we have a lot of programming commands available to us in these script files that we can create. So the kinds of transactions and different commands that we have available could be dependent on the database management system that we're using. So we're using SQL Server that gives us access to these transact SQL statements that we're going to use. But if we were using Oracle or some other database management system, we might have a little bit different of syntax because these scripts are not exactly SQL. They're kind of off to the side, right? So they're a function of the database management system. Now, so far you guys have worked with scripts and you've seen that scripts are batches of commands, right? And so those commands might be select statements. They could be insert statements when you were adding test data into your table. They might be even update statements if you were updating the data rows in your table to make something work as you were creating your information. Now the batches are separated by the go command. So we have been using that, and you guys, like I say, have encountered a little bit of that as you've created your database, and you saw things like the view said it had to be in its own batch. That meant we had to have a go command before we had our create view statement and after our create view statement so that it lives alone in its own batch. Now there are 5 statements that we have to have in separate batches. Let's see. They are, I'm going to put this indented, must be in separate batch. We have view, procedure, which we haven't gotten to quite yet, function, trigger, and schema. So create statements on all of those object types must be in their own separate batch. Now, whenever we say this is a scripting language and it's a batch of commands here, we could be talking about any sort of SQL command. Let's try a script here. I'm going to open SQL Management Studio. See if I can find the right endpoint address for us. Remember what I made my password. Oh no. One of you guys will have to get in there and fix it for me. I know what it is. I just got confused with my C# one. All right. So in my database, I'm going to open a new query window, and I'm going to try a script. So there's several things that we can do here.
Let me guess. Use AP?
You want to use AP? That sounds good.
Oh, I thought that was what you were going to use anyways.
We can. No, that'll work. Let's try it. Now, this first script that we're going to use, it's going to use a lot of different syntax, and we'll go back and kind of review what we did. First of all, we're going to declare a variable. I want to put some comments in this script. So I'm going to use this dash comment that we hadn't really used much before because it looks pretty nice. Let's see if I've got this one. Total do. So this script will select the sum of all invoices, calculate the total due, now whenever we're creating these kind of SQL batches and scripts, these could be things that we use in production in our system. So we really want to document them because this is the kind of source code, just like a program, that we need to maintain and control. So we could go ahead and do some really formal comments. Let's say script. This is going to be the invoices total due. And let's put our developer information here. That would be you. I'm going to tab this over. And I'm going to put the date that we've created this because it's a little different than just a select statement. We're going to be using this all the time, and our company is going to be dependent upon it. So I'm going to repeat that purpose a little bit. Now, within our script, the first thing that we're going to do is declare a variable. So just like our other programming languages, we have our specific syntax we have to use for variables. So I'm going to start out with the keyword declare, and then our variable names when we're working with SQL Server always start with the @ sign. So here's my @ sign. And we want to call this variable total due. Now, just like our other programming languages, again, SQL Server is type oriented, so it wants to know what kind of data type this variable is going to be. So we're going to declare this total due as money. So all of our different data types that you guys have evaluated and reviewed are data types that we can use for variables. Now we want to update the value of total due, so we're going to use the set command. So notice SQL script syntax is kind of like somebody took pseudocode and said, we're going to make this into a real language, we're going to use it around SQL. So in pseudocode, where they say you're going to use the word set to change the value of a variable, with SQL Server scripting, we actually have to use that keyword. So what do we want to set the total due variable to? Well, we're going to run a select statement to get that value. We're going to select the sum of that same old calculation, invoice total minus our payment total minus our credit total. And we want to select that from our invoices table. So just like a nested query, we're going to have this query embedded within the script. So now instead of having that number just display as the result of our query, that invoice total number, and of course we could select this, right? Can we select it and run it? Mad at me because I don't have my use AP. Let me run that and then see if I can run this select statement. Ah, there I go. Now it says that we have like 26,220, and it's just displaying that output because it's our result set. Well, we want to take that output, that value, and put it into this total due variable. So that's what this set statement is going to do for us. Make sure it's got your use AP. I had to go up there and run that one statement by itself, and then I was able to run that select statement separately. Is it letting you do it?
So, don't like have use AP, but
Yeah, just go up there to the top and highlight it and click execute. So that's the database that you're in now. And now you can go down to the bottom and just run your select statement. Once you run that use statement, that's really the database you're in until you change something. We've just gotten in the habit of using the use statement all the time so we know we're in the right place. But it'll keep us within that database. So,
why did you have to run the select statement again?
after I did ran the use AP.
No, I ran it, and it said command executed, and then I had to highlight the select statement.
Mm-hmm.
because we're just setting that variable to the value that we're not actually
Right.
using it to return anything.
Right, so nothing's happening in our script right now.
Right.
If you run it.
Find that you're specifically highlighting the run script, so that's why.
Just to see that results of that select statement.
Can you repeat the select statement afterward to have it automatically do it?
We won't need to. So we could just print that number. So let's do that. After we've got our variable set, let's check it. We can use if statements in our scripts. So we can say if our total due is greater than 0, print total invoices due equals $, and then we're going to close our string and concatenate our total due. But to actually display it properly, we're going to use the convert function. and convert it to a variable length character with that format of 1. Now, if that if statement is not true, we'll execute our else clause. And in that one, we'll say print invoices paid in full. Semicolon. So it starts looking a little bit more like a programming language here. Zoom back out a little bit so you can see that whole line. Now that's our complete script. So last time when we looked at our views, the view looks somewhat like this, right? Because we have this embedded select statement, but we were saying create view, and so we were actually saving that SQL syntax in our database. Script is different. We're not saving anything in the database when we run this script, right? It's not a saved entity, an object in the database. It is just an SQL file of commands. So whenever we run this, we're just running it. So let's run it. We should see our output with our total invoices due amount that we selected earlier. So yeah, we could continue on and put that select statement in our script again. Let's try it. I'll just copy it. And say, well, I want this select statement in here too, and put a semicolon at the end.
Management Studio is not very helpful when it comes to warnings.
Do what?
The Management Studio isn't very helpful.
Not very helpful at all, is it?
No, because it says right here, must declare the scalar variable total due.
So that's your declare statement.
Oh, yeah.
So you got a typo there if it's not seeing it. Now, when you run, let's take a look at some errors like that. But first of all, when I put this select statement in, notice I'm getting 2 types of output. I'm getting my results set, which is just the output from the select statement. And in my messages tab, I'm seeing that print output. Now, let's see what you've got, Austin. You got a typo. So let's put a typo in our variable name. Up here, I've got total due declared. And in my set statement, if I make a typo like delete the A, we should see that red squiggly, and it says that must declare this scalar variable total due. So if you see that message, it means it doesn't see this variable being declared, so there's a typo. Now, what's scalar? Scalar just means that it is something that holds a single value. Because remember, with SQL, we're used to being able to have result sets. So we can have values that have sets of data. A scalar value is just a variable, just something that holds one value, like our total due. Holds that one value, that total amount due.
So it wasn't actually a typo that was wrong. It was the go statement. Go statement will mess it up too.
Oh, okay. So good point. So did you have it after your declare?
I had it after the set.
Let me put that in and show everybody. Because remember, the go statement separates us into batches. A variable scope is only one batch. So when we declare a variable, we can't have it cross over a go statement. So this is the end of that batch, the end of that total due variable. So that's what
function called sort of.
Yeah, so it's like this particular batch is what we have in this script that can see it. So good points. Those are all things that could get us. So I'll get rid of that go.
The go there says, I'm done.
Yep, done with that batch. So the variable scope, is no longer applicable. It's out of scope.
So you can just make a giant. You can make a giant file of batches that do
Different things. Yes, you could. And that's what people do in companies and things that they want, you know, these certain things to happen every day or every afternoon or whatever, they'll put this whole batch together. And that's kind of the keyword batch, because it means it's going to happen sort of like all at once. So we go batch of orders or updates or whatever we want to do. So this is our first script file. Let's put some notes in about that, what we just did. So here again, we see that our batches have to be separated. I'm going to back tab and put T-SQL commands. So we saw that we have use, and that's our database to use. And we've already used that before. Print prints out whatever data you have. Now, two data commands that they say they're not going to tell you about are go to and return. We want to talk about the guy in my C# class that did his presentation on the go to command, because our textbook actually says these commands exist. They will not be discussed. So let's put do not use. And we'll just be that bold and beautiful to not use those statements.
Old procedural language type structure.
Old procedural branching structure that makes programs awful.
Oh, it's archaic. It's archaic.
It's archaic, yes, that's a good word.
If you find yourself needing to use one, you've already messed up, go back and start.
You dug your hole, give yourself a ladder out.
Go to exit.
Exactly.
You remember that.
You can go to exit. That I'll do that one, but no, not really. Find a better way. So then we have some other commands that control our flow. So the commands that control flow, we saw our if, else statement. So that's one that we're pretty common with. Now, we need to find some specifics about that, though. You know, does it just do one line of code after each? How does it work? We didn't have any curly braces. Oh, my God, what do we do? How do we know when it starts, when it ends? Things like that. So we have to get some details figured out. Now, another structure that we have is the begin-end structure. And this defines a statement block. Again, it could have go-to ramifications, so we might not see it as often as we would other structures. We have a while structure for looping. We have a break to exit the innermost while loop. We have continue, which returns to the beginning of the loop. We have try catch. So just like our other programming languages, we can use try catch for error handling or exception handling. And then the go to and return. So we'll leave those out. Now, one other category, we have other keywords or commands here. Oops, indented too far. Our use statement, we've seen. Our print statement, we've seen. Now, declare, we saw that's used to declare a variable. Set is used to set a variable's value. And exec is a command that we hadn't used yet. And this is used to execute a stored procedure, which we'll be looking at in a week or so. But we have a lot of stored procedures available to us through the system on the system tables. So something that we might want to look at. So that's basically all of our syntax in a nutshell that we have for the T-SQL commands. Of course, we can make that into something fun and adventuresome as we do some things. So let's see what we can do. All right, before we get too far, a couple of other terms that we want to put in our notes. Scalar. We saw that again. We had seen that term back at the beginning of the semester, but it hadn't really popped up a lot. Scalar meaning one value. So whenever we're working with our scripts, we have to be careful, right? Because if we look at this script, and we could go ahead and copy this script into OneNote as an example script. I'll copy it. I'll zoom out a little bit so I can paste it here beside my notes. So there's my example script. And of course, you could use the snipping tool if you wanted to retain the color. I might be able to, let me Control Z here. If I paste, keep source formatting, still not keeping the color for me. Darn. Too bad. Okay, so I've got my script here. I've got a nice sample. Everything looks good. Looking at this script, our variable total due, since it's a scalar value, only expects one value as a result. So if our select statement were changed to return another value, a second value, our script would not handle it properly. So we have to make sure that our select statements align with the code that we're using in our script files, so that we are just receiving that one value to load into that variable. Now, another thing that we can do in a script is we could set up a variable to hold the name of a table. So let's open a new query window. And I want to use AP. And for this one, let's do real quick. This script is going to set a variable to a table name so that we can use a variable to determine what table name we want to select from. Gives us a lot of power. Sometimes we don't know that we need that power until we come across a situation where it'll help us. But it's pretty handy. So in our script, we're going to declare a variable @ table name var, and we're going to say it's a variable number of characters up to 128.
Does that include, does that only include like the table, that includes all the data in the table, or just the table?
Just the table name. So we'll see. So let's set it. We're going to set that @ table name var to invoices. And of course, we could prompt a user for this table name or have a list or something that they selected from. And then we can select the data from our @ table name var. It's griping at us, huh? Is it going to work anyways? So notice it could be an issue. I'm going to try to run it. It says, do I have a typo? Table Must declare it.
Is invoice in the AP?
Oh, I need a S. You are so good.
That didn't help. I still have the same error.
Didn't help ya? Must declare. Well, it shows us in our book. Oh, look at that, how mean it is. It says you can't do this. It shows us this big example. Can't do this, it's invalid. So what do we want to do? Because we just realized this would be really helpful to us sometimes to be able to do this, and then we can't do it. Well, we're going to look at being able to do this later in the chapter when we're working with dynamic SQL. So keep that in mind, that we'd like to be able to replace that table name with a variable in our select statement, because that would be pretty handy for us. So something for us to look forward to. Woohoo. Now, a little bit more code for us to try here. This one is quite the thing. Let's try it. First, let's take a look at what this script is going to do. We can look at our declare statement. This is the overall syntax. We can declare multiple variables in one declare statement, separated by commas. Notice we need the variable name and the data type for each one. The syntax of our set statement, we can only set one variable. Now, we could actually select multiple variables. So I could select variable name 1 equals my invoice ID, variable name 2 equals my vendor name. So I could set multiple variables in my select statements. So this script that we're going to create declares multiple variables: our maximum invoice, our minimum invoice, percentage difference, some counts. So we're going to use a lot of different pieces of data, and we're going to select all of those from our vendor and invoices table, looks like. So let's create this script. It's got a lot of good examples in it. So I want to create a new query. This script is going to be a variable-oriented script. We're going to use a lot of variables. So in our script, we want to use the AP database. And then we want to declare. And what we're going to do in our declarations is kind of declare our variables by data type. So first, we have our max invoice. That is money. And our minimum invoice, that is money. Then we're going to use another declare statement to declare the percent difference variable. And it's going to be a decimal value with a size of 8 with 2 decimal places. Then we're going to declare our invoice count as an integer and our vendor ID variable as an integer. And we're going to go for a specific vendor. And of course, again, we could have some programming going on where we ask a user for this vendor ID or get the vendor ID from some other process. But for us, we're actually going to set the vendor ID variable in our code, and we're going to be looking for vendor 95.
I was looking at the book,
Uh-huh.
and it looks like you could actually do one declare statement and separate them by commas.
Uh-huh.
And I mean, do at the end of money, put a comma.
Right, we could keep them all. They just grouped them by data type.
Yeah, I see you're doing this for clarity.
Mm-hmm. But you don't have to. You could put all of your different data types together
If you want.
if you wanted. Uh-huh. Yeah. If you're one of those engineering types that wants to save on white space and not have any extra white space. Because I know engineers hate white space.
Or think you're you're setting it up so that you're indispensable.
Oh.
You can translate it, nobody else can.
Nobody else can figure it out.
Yeah.
Okay, now let's get our max invoice variable here. So for our max invoice variable, we want to set that using a select statement. And of course, we're going to select our max invoice total from invoices. And then we want to have a where clause on that select statement. We want our vendor ID to be equal to that vendor ID variable that we have created. Now our entire select statement is embedded within parentheses, since it's kind of an embedded select. Now that's a good way for us to get that minimum invoice or maximum invoice value. Let's look at another way. Go over, you silly thing. I'm having a fight with it. I want to set our minimum invoice, and let's try it a little bit different of a way. Oh, I don't want to set, we want to select. So let's select minimum invoice. So doing it a little differently. And we're going to do that by saying select min invoice equals min of our invoice total column. Then we also want to select, I'm going to tab over and kind of try to line these up. Secondly, we're going to be selecting invoice count from this query, and we want to set it equal to count of all the invoices. We'll be selecting both of those variables from our invoices table, where our vendor ID equals our vendor ID variable. So differences. First of all, this first one uses the set statement, and we have a embedded SQL or embedded select statement. So it's within parentheses to set that variable. Our second one, you see our select statement itself, it's indenting for me, loads the variable data. So just a little bit different of syntax, but both perfectly valid. So it adds a lot of flexibility. It also makes it sometimes a little bit confusing if you're looking at somebody else's code that might do things a little bit differently. than how you're used to. Myself, I guess I would say that I prefer the second, because to me it's clearer that I'm selecting this variable equal to that and the second variable equal to that. So, but the first way is a very valid way too, no problem with that. Either way is fine. So now we've gotten our maximum and our minimum. So we need a calculation to set our percent difference. So we're going to use that set statement. And the variable that we want to update is our percent difference variable. And we want to set it equal to a calculated value. So we want to take our max invoice variable and subtract our minimum invoice variable. And then to calculate the percent difference, we're going to divide that difference by our min invoice times 100, so that we're getting a full number there instead of our cents causing trouble.
Do we need to have the min invoice times 100 in parentheses? Or will it figure it that way?
Is it going to make any difference? Because we're going to subtract.
No, it may not.
But it might. I think, I don't know.
It'll do what's in parentheses first, then it'll
Yeah.
do multiplication, then division.
Because it's going to make the difference whether it divides by min invoice times 100 or just by min invoice.
You want the product multiplied by 100 to get a percent.
It would seem like it, doesn't it? So let's put that within parentheses.
But we need that in parentheses. I think he's right. I think we need to be the.
Because there you are multiplying the invoice by 100,
Uh-huh.
which is basically going to say if the invoice is $100, you're going to make that.
Yeah, it needs to do the times 100 last.
Last,
Yeah.
so it's
Yeah.
good. Okay.
If you're going to
Like
put
that?
parentheses, you should put parentheses prior
Around
to
that
max
first
invoice and
set.
after min invoice.
We can do that just to clarify that it was thought about.
Yeah.
Right?
That I think would give it the order of operations.
Should be good. Perfect. Now, let's do some print statements to output this wonderful data that we've collected. First, we're going to print that our maximum invoice is $sign plus. We're going to convert to varchar our max invoice variable using that data type 1. And then we're going to add a decimal or a period at the end. So our final print is going to say maximum invoice is this $sign amount, and then we're converting to format it as a number with the commas and all that great stuff. And then we're adding a period at the end. Now we want to do the same basic output for our minimum. Min invoice plus our dot. Now our next line, we're going to say maximum is space. And then we're going to print out our percent difference. Now we're not going to do that one formatting to it because we don't want the 2 decimal places and all that stuff. So we're just going to leave it as the default. Continuing on. Period at the end of that one. So the total for that one says print Maximum is, and then we're converting our percent difference to a varchar, and then we're adding percent more than minimum, period. And then finally, we're going to print out the number of invoices, our count variable. So we're going to say number of invoices. And then we want to convert that. Our invoice count. You can try it, see if it works. Aha, yay. So my results say that my maximum invoice is $46, my minimum is $16. Is everybody getting the same thing? Getting differences?
Can we see the last line?
Sure. Now, as we're looking at these variables, these are our scalar variables that are just holding a single value, but we can actually create variables that hold a whole table when we're working with our script files too. So we can create a temporary table that's inside of a variable. Lots of great things that we can do. Is it working for everybody?
No,
No. What's it matter to you now?
I think it might have to do that. Doesn't like percent.
Because you've got an X and percent of it.
Ah, I love looking for that garbage.
Now this batch file, you could save it if you want, or you can copy and paste it into your OneNote notebook. You could save it as an SQL file and insert it as an SQL file into your OneNote notebook.
I thought you could do that.
You can just do anything that you want. My connection has died here. Okay, so let's look at working with the entire table as a variable, and then we'll stop for lab time here. They've got it. So in my notes, I have this scalar is one variable. I think I'll add that it's a variable that holds one value. And then I can put that we have a table variable. And this holds an entire table. We start getting into stuff that's really cool. Did you guys figure it out? You're awesome. Okay, so let's make a table variable here. I want to create a new query window for this one. And let's see, this script. This is really going to be big vendors. So we know that our management has often asked us for the top 10 vendors or the top 10 invoices or whatever. Makes more sense with customers, but either way. It's to give you guys examples. So we'd like to save off a script that gets this information for our management because they seem to like it so much. So let's create this thing. So this will be info about the biggest vendors. This is going to be our AP database again. And our declare this time, still going to be the same type of variable name that starts with the @ sign. But our data type is going to be table. Now, once we declare our data type as table, bless you, everybody sneezed all at once. That's always so interesting. So once we declare our data type as table, then we have to have a column list. It's okay. We can start our column list. We're going to have a vendor ID that's going to be an integer. And we're going to have a vendor name that is a variable number of characters, a max of 50. That's the end of our column list. So we're only keeping 2 columns in this table. Now, to create our table or put some data into it, we need an insert command. So we're going to insert into our big vendors table that we just created as a variable. And what we want to insert is going to come from a select statement. Now we need to select the exact same columns, right? Otherwise it's not going to match up. We're going to select from vendors where our vendor ID is one of the vendor IDs in this nested query. And our nested query is going to be select vendor ID from invoices where our invoice total is greater than 5,000. So we start out with our deepest inner query. We want the vendor IDs that have this invoice total greater than 5,000. We're going to take that result set and use it in our where clause to select the vendor ID and vendor name into our big vendors table that we just created as a variable. In the end, after we've loaded up data in that table, we're going to display that information by selecting everything from our big vendors table. So with our company, we don't owe that many companies, so our vendors table is not super huge. But if we were working for a really large company, we could have thousands and thousands of rows in this, in our vendor table and in our invoices table that are being looked at as we query this. Let's run it and see if it works.
But you had a lot, 5 million would probably be your cutoff point. Hooray!
Did it work? Yay. So once our batch has finished running, does that table exist anymore? No, it's gone. Its scope is only our batch. Uh-huh.
Mine's telling you it's not to think that people variable and include it as a
Is there a typo? Do you see it?
sometimes that in makes it happen.
You found it though. It's happy now. So this is really powerful. We can do some programming, create a temporary table, do some things with it.
Now, if you have, question, if you store like a whole table
Uh-huh.
into that query, and then you do an insert into, does that update only the script? Or does that actually update the table?
Well, it's updating this table, but this table only exists as long as our script is running, because it's just a temporary variable that we've created in our script. So
you can do stuff and not affect the actual data.
right, exactly. You're not affecting the real one. You are potentially affecting a lot of memory, depending on how much is in there. So that one works really good where we've got all of our top vendors here. They bring up some things, though, in our textbook. Here is a little figure here that has two. Let me see what we've got. 14-5. Where's our little thing? It doesn't say. So our table variable is one thing, but we could also use temporary tables. And a temporary table exists for the duration of the database session in which it's created. So a little bit different of scope. So when we create our table variable, that's just for this batch. But if we created a temporary table, then we would keep that table as long as we were using the SQL Management Studio session. So we could have some differences going on there. So let's look at this figure 14-5. It says it presents two scripts that use temporary tables, but I'm not seeing where the figure is actually identified. Is that one right here? So here we go. So the important thing is that our derived tables are more efficient to use than temporary tables. You should use them whenever possible. So we'll add that to our notes next time with all of the differences about the different types of tables, be it a variable or a temporary table. Well, let's stop there so you guys have some lab time to wipe out that last one, unless you don't need any lab time. We'll try to finish this chapter up next time so that we can move through our last couple with a little bit more programming stuff, so kind of fun. Any questions about it? Got it all? All right.